introduction to SELinux. Before I start, I would like to see how many people are using SELinux at this moment. And by using, I mean in enforcing mode. Okay, nobody. Who is using it in permissive mode? Okay, at least a few people. So I presume everybody else is still running it in disabled mode. Or some of you don't know what it is, maybe even. Okay. That's the first thing. Then the presentation itself is a short introduction, so I don't go into the full details of everything. First, who am I? My name is Toshaan Bharvani. I work as a freelancer for my own company. I've been involved with the CentOS project. I like to keep things secure, both in software and hardware. So there's my interest. So I'll be giving a short introduction, then how to use SELinux, the basic stuff, what are the states, how you can manage it, and how you can generate simple policies. I'm not going to talk about writing policies because that's a little bit complicated. And if you are using Linux as a normal LAMP stack or in a usual way without custom software, the generation of policies has become very easy, and some policies are already pre-generated. So yes, the introduction. I presume everybody knows the traditional Linux file security system, what I like to call the 3x3 system. It means you have a user group and others, and you give it read, write, or execute permission. So for instance, if you have an Apache daemon running, Apache can only read files it has access to with the Apache user, so you have to give it read access. If it needs to write to those files, you have to give it write access. So what is SELinux? SELinux is a security enhancement. It uses a mandatory access control system, and it runs within the kernel itself. It does that by using three types of enforcements. The type enforcement, the role-based enforcement, and the multi-level security. I won't be talking about multi-level security because that's more complicated. And unless you're using newer versions of Red Hat or SUSE or any other distribution, you won't have those options yet. They have been enabled beginning of February this year, so not all distributions have them yet. So how does it control the access? It does that by type enforcements, which are basically policies that allow certain types to access or not access certain parts of the system. It does that by roles, so you get a type of a user-based system, but in place of users, they're called roles. So a certain role can access a certain daemon or a certain policy. And the multi-level is basically that you have multiple types, multiple roles, and you define roles based on types and other policies which are allowing multiple security levels. So you can have Apache running for a certain part with a policy number 1 and with a different policy for a different type. Again, I'm not going to go into that for this presentation. So if you want to look to it visually, this is how we normally secure Linux. So you can have access to whatever daemon, and whatever daemon has access to the kernel is basically allowing you to get to the kernel, then get through the file system and to the daemon itself. So for instance, for people who were using it on the desktop, Skype had a very nice old feature that they used to read out whole your etc. Files before it used to execute. So in the old way, because it was running mostly as your own user, whatever your own user could read in the etc. Folder, Skype was also reading at that point. If you look at SELinux, it's basically a module that runs within the kernel. And around the kernel there is a database which is maintained, which is called the policy database, and has all the policies, the roles, daemons, and everything else in there. Based on that, a certain daemon will be allocated with a label. That, for instance, Apache is called HTTPD_T, and it can access only whatever is labeled with those policies. So you basically confine Apache to a certain compartment of your system only. So if your Apache daemon would get compromised, it would only allow you access to that small part of your system, in place of giving you system-wide access. So what are the features? Of course, you have policies which allow you to separate daemons. You have you can change policies, which was in the past not possible. So if for people who are still running Enterprise Linux 4, policies were predefined and you can change them. In 5 you can change them already, and in 6 you can even change them on the fly. There's a separation between the system itself and the data. So daemons run and can only access the data that they are allowed to access. You have a better control of file systems, sockets, networking connections. So it allows you to secure everything to certain parts of the system. So the old version was basically you had a module in the kernel, and that used to execute. Policies were generated from the kernel, and they were basically confining the kernel-based stuff. That was the old version. That's for people who still use Enterprise Linux 4, that's what you will have. What we see more and more happening is that, for instance, Apache daemon or even Postgres have SELinux enabled versions, allowing you to confine them in the application itself. Not only through policies, but when you compile it to make certain types available in the binary form itself. And what we would like to have, but we don't have yet, is that all features are available and that all daemons are confined by SELinux. So where can we find SELinux? For people who use Red Hat, it's from version 4. The version 4 is a very old version, a very difficult version, and doesn't have all the features I'll be showing today. Version 5 does have all the features, except for the policy generation you need 5.4 or higher. The same is applicable for CentOS or Scientific Linux for people who use Scientific Linux. In Novell, if I remember well, it's from 9.2 Service Pack 2 or something like that it has been added. But in the 10 version and the 11 version it is available. In OpenSUSE it's also there. It's available in Gentoo, but you have to recompile whole your system. So the base version you get from the Gentoo website does not have SELinux enabled by default. You need to manually compile whole your system again. In Debian and for Ubuntu, you can just do apt-get SELinux. It will install all the modules. You will have to reboot your system because the kernel module has to be enabled. By default, Debian kernels and Ubuntu kernels do not have the SELinux module on it. For other distributions, I don't know that much about them, but I know that there are many other distributions who have also started using it, as it is in the mainstream kernel already. So, for most people, I saw that most of you are not yet using Linux, so SELinux, so I presume this is quite true for you. First and for all, Theodore told that life is too short for SELinux. That is because it is quite complicated, and it used to be very complicated. Today we have made it a little bit more easier, and policies can be generated near automatic. And another big issue I see is that upstream vendors require you or recommend you to disable SELinux. So for people who use Rafa or Oracle databases, the first thing you see, I think, in the introduction is please disable SELinux. we are working with the upstream vendors to or enable it through separate packages, or to change the methodology that they use, allowing people to use SELinux also. Then, what is good about SELinux? Where does it come from? It comes from the NSA. We would presume that they have security in mind, and that they have contributed this to the open source world. So therefore, open sourcing a security system gives us the ability to review that and to see that that security system is really good. So that is the mechanism behind it. Why would you want to use SELinux? Because it confines your daemons in compartments. Daemons are also confined on network bases, on file system bases, and on different levels of the execution it can do. Nowadays it's not difficult. It's quite easy to do. It does increase security. I've done some tests with MySQL mainly, where I've had or done SQL injections, and in 50% of the cases you see that SELinux catches them and doesn't allow execution of those things. It's not perfect, but it does increase security. And it stops, of course, bad daemons to be bad. Still needed once in a while. So, is that clear for everybody, or are there questions already about?
If you try to make your system more secure by running every daemon in a separate virtual machine,
yeah.
Just secure, more secure, less?
Well, it depends. Virtualization by itself is not secure unless you use the same security you use on your own system. So just because you run it in a virtual machine doesn't make it more secure, the daemon itself. If you secure your virtual machine as it should be, then it is more secure. But just putting it in a virtual machine doesn't make it more secure, because okay, you can still get into the virtual machine, still crash the machine, as you would do with any other system.
Then you have only crashed one virtual machine.
Yeah, okay. But then you would have to be able to virtualize everything, and every separate daemon would be virtualized. So you would still have interconnections between the virtualization. So if you crash or if you get into one, you would be able to get from the networking stack to the other ones. Again, you need to secure your environment, whatever it be, physical or virtual. Any other questions?
Yeah.
Yes?
What's in the manual, if you use a database, please disable SELinux?
Sorry, I didn't understand fully. So if you use?
You say in a manual of a database.
Of Oracle database, yes, it's written on the third or fourth page, please disable SELinux.
Yeah, why is it?
Because they, as Oracle, do not support SELinux, first and for all. And second and for all, because they don't want to support it. Because that means that they need to invest more time into understanding what SELinux does, then maybe and most probably adjusting Oracle database so that it would run properly. That is more time and money that they need to invest, and customers would most probably not want to pay them for that. So it's basically just an issue about do we get money from it or not? And that is in most of Oracle's business model like that. So for instance, for Zarafa, I've spoken to them. They are working with us to get it integrated, but it's going to be difficult, I agree. But with Oracle, you can't even talk about it because it doesn't make them any more money. So they're not going to do that. It requires them to invest in security people, to understand the system, to do many other extra stuff that you wouldn't normally have to do.
But is it safe to disable SELinux?
They claim it is safe. I have run tests and I don't find that that is 100% true. It would be safer with SELinux, but that is my opinion and that is their opinion. And as they are the upstream vendor, you can't change much about that. What I've done with one of my customers is You enable it in permissive mode, you debug it, write a policy, enable it back in enforcing mode, and then if you have problems and Oracle needs to get on the machine, you just disable it through the command line at that moment while Oracle is doing their work on it. And then after they've done their work, enable it again. Or you can disable SELinux specifically for that daemon also. And run it on the rest of your system still. So those are the solutions, but getting upstream vendors to accept it is a little bit difficult at the moment. Any other questions? Okay. So now I'll explain you how you can use it. First and for all, SELinux come in multiple states. So you have the enforcing state, the permissive state, and the disabled. Disabled, as it says, as the word itself says, means it's not on. Permissive mode means you load the kernel module, but you only log whatever is happening. You don't tell daemons that they may not execute whatever they want to execute. This is good if you are running it in debugging mode, or if you want to generate policies, seeing first what the daemons do, generate your policy and run your production in enforcing, and then you are able to apply that policy directly there. Enforcing obviously means that it's enabled and it tells the daemon what it can and cannot do. Now, in enforcing mode, you have two sub-modes. One is called targeted and one is called strict. And then you have the MLS version also. So the targeted means that you only use a certain set of daemons that you target. You can specify the list that you want. By default, Red Hat uses mostly the LAMP stack. And those daemons will be enforced and will have SELinux enabled on them. So this allows you to, for instance, run Oracle DB separately and not have that confined with SELinux, but have Apache confined by SELinux and other daemons by default. The reason why by default you have the targeted mode is because SSH is not in the targeted mode by default. Reason being that most people like to change their SSH port from 22 to something else. If you do that, then you have to first add SSH to a different port, or allocate SSH a different port, and then only enable it, because otherwise you won't get on your machine. Especially if you're SSHing to a remote machine where you don't have physical access, that might be a problem. I'll explain that later in more detail, how you can do that and what that exactly means. If you run it in strict mode, all daemons that run are being confined by SELinux. So every daemon you can imagine on your system has to comply with the SELinux rules. So if you have a system and you're not sure, do I have SELinux on this? Does it work? In what mode am I? You can just execute as a status and it will give you an output. No. So, where did my, here. Can everybody read this at the back? Yep, okay. So if I execute as a status, it tells you that SELinux is enabled and that the mode is currently enforcing and that I'm using the policy type of targeted. Okay. Now, that tells you whether SELinux is on or off and in what mode you're running. Now, let's say you want to see what processes are running and what are their SELinux tags on them. So you execute your normal PS and you add the capital Z. So the capital Z is what you do to add or to know what SELinux has as policy, as type, as role, and then you can see that. So the netstat gives you the ports that are open currently and what are the SELinux tags of those ports. The ls gives you the file system labeling. So for instance, if I do that here, I get here, for instance, that I'm in the root directory. It's a user directory, it's an object, and the label that it has been given is user home. if I look, for instance, at var www, you see that it is here HTTP daemon file tab, and in this it is an HTTP daemon sys content, so that is what the contents of Apache can read and write to. So file systems normally have your security as in the traditional read, write, execute. Now for SELinux you have labels that have been added. So for instance, if you want Apache to read a certain directory like var www, you have to give it an HTTPD file type. There are subtypes also in there, so you saw that you had the content sys type, which is basically that it allows you to read the content of those folders. If you move a file from a certain type to a different, so when you create a file, it gets a certain label. Let's say I created in my home directory, it gets a home type label. I move that file to my web environment, so in var www HTML, for instance. Apache would, or moving does not copy the context of the location, but of the of the source. No, it moves it with the context of the source and not of the destination. That's the right wording.
Explicitly give it the HTTP type.
Yes. So you need to change the context afterwards before Apache would be able to read it. You can do that manually or you can do that automatically. I'll be showing that in a few slides. But that's what you have to remember, that file type labels are there to enforce security, that those files can only be read by a certain daemon, and that is defined in a policy. So let's say I made an HTML file in my home directory. I move it. By default, Apache would not be able to show you that. It would just give you an error. So what you can do is change it. So you just use chcon, so change context. The -r is to do it recursively. -t is to give the type. So in this case, I would be giving the HTTP daemon sys content type to user server www. That changes the context of that location to the right file label as per the policy of the Apache daemon. This allows Apache daemon to read those files. The usual normal Linux permissions still apply. So if you only give it read writes, it will only be able to read. You still need to give it write to those files. Now, by default, there's a database with all the default locations. So when you boot up your system, it will look that, okay, for instance, in Red Hat, var www HTML uses the context HTTPD sys content T. If it will find files that are not labeled correctly, it will relabel them automatically. This is done at boot, but is also done by an interval because there's a daemon called restorecon which does that for you. Now, let's say I created my own directory, user server www, which is I think the default in Debian, but I want that on a Red Hat system. Then by default that would get unconfined label, because in the database it doesn't know what this location should have as the default file label. To do that, we use SEManage, which basically writes to your database, and we tell him that the file context of this location should be added to the database with the default type of HTTP sys content T. Doing this makes it a permanent solution. So that means if your file system ever gets relabeled, it gets relabeled to this specific context. This allows you to have always the right context with the right location. If you don't remember what the default, or you want to have the default context on a certain folder, you use the command called restorecon. So R again for the recursive, V so that it tells you what it's doing, and N because you want to normalize it to the normal system. Then another issue is that if you run SELinux at installation time, everything gets labeled correctly as per the default database and the default policies. Let's say you disabled it first, you installed whole your system, you added new daemons, you did whatever you had to do to make your system production ready, and then you say, let me enable SELinux. You will have a problem because everything that was written between your installation and your final time that you enabled SELinux did not get the default context, because what it does is when you install files, it automatically relabels them to the default context, but as SELinux was disabled, it was not doing that. So you need to relabel whole your system. You do that by touching a file in your root file system called auto-relabel and rebooting your system. You have to still execute generate home dircon because the home directory is not relabeled automatically with the automatic relabeling. This process is a manual, is a sequential process, so it goes over whole your file system. If you have a 300 gigabyte hard disk and you need to relabel that, it will take time. Your system does it before it boots up anything else. So what it does is it loads the kernel, it loads a small shell for SELinux, then starts relabeling it, then unloads the kernel, reloads it again, and then goes through your normal process. So this means that you have a quite long downtime. At the moment, it's not possible to do it on the fly. So it's not that you can do it on a running system, relabel it, and then reboot. So that would mean that only your reboot time is your downtime. You would have to do it when it's down totally.
Yeah, sorry.
Yes?
I don't just set correctly too. What does this add on top of the normal file permissions? Because those are enforced by the kernel too.
Yes. So let's say in the example of a web environment, you have, for instance, a Drupal instance that you created in your home directory and you are using, or you created on your local machine. You upload it to your home directory and then move it to the right location. You would have to give it the right file permission as you usually do, but by giving it labels, you tell that Apache is the only one who can read it. Because giving the right label, let's say you are with a group of users and there are multiple users who can, who are member of the Apache user, it allows them also to read those files or execute or whatever permissions you gave them. But it doesn't confine that only Apache can read them. If you, for instance, put MySQL in there, MySQL would also be able to read all those files. And this adds an extra layer of security by saying that only files which are labeled correctly can be read by those daemons. And it is only that daemon that can read it. So MySQL, for instance, can only read by default varlib MySQL. But let's say you are running that in a different location. You would have to relabel that, but you would have to give it the default permissions. You can give that, say, a permission for multiple locations. So let's say you have a home directory where you're going to put your MySQL data per user. The MySQL would, if you would get into the MySQL, you would be able to read all of them. Here, you would be able to confine that a certain daemon can only read that particular part and then have daemons subdivided. That's what you can do with MLS, and that's what the end result is supposed to be. That
Okay, but so it only gets really interesting from MLS home.
Well, it depends. If you want to do very complex things and what you see as in, I want to add more layers of security, yes, MLS is the way to go. But we had to start somewhere, and we had to make something already more secure than what we had. But MLS is then the way that you would want to go. And then you would be able to say that MySQL under that particular daemon uses this policy with that file type, and only that user could get on it. So if MySQL is compromised, then only that particular part of MySQL gets compromised. That would be the end result. I explained you about file systems. Now it also confines ports, so networking connections. So by default, for instance, Apache can connect to port 80, 443, 8080, and 8443. But let's say we want Apache to run on port 8181. So if you do your normal service HTTPD start, it would give you error, that's all. It won't tell you what, and in the log file of Apache, you would not be able to find it very easily. You would have to dig more into the varlog messages and the varlog secure to understand and see what is happening exactly. But if you go through as a manage and you tell him, show me the ports, list all the ports, you would see that Apache would only come with a certain limitation of ports that it can connect to by default. So if you want to, again, add a new port to the database, you use the command called as a manage. You tell him, I want to add a port of the type HTTP port T with protocol TCP 8181. Once you have done that, you can start the Apache daemon on that port then. As of Enterprise Linux 5 and all the newer versions of SELinux, there are predefined policies. So for instance, Apache, what I use as my example, has a predefined policy already. For people who use Zarafa, that doesn't have a predefined policy by default. So you would have to generate a policy or download it manually from their website. If the policies are generated or pre-generated, they tend to contain booleans that you can enable or disable. So for instance, Red Hat has made a policy for Samba, whereby Samba cannot read home directories by default. So if you want to get a list of all the booleans that are available on your system, which is basically going through all your policies, you just use the command get as a bool. So it gets you all the SELinux booleans, and then you can grep on whatever you're looking for. In my case, it's Samba. So let's say you get a list of all the possibilities, and then you can set it to a different type. So by default, Samba enable home dirs is off. If you want to set it, you just change it to on, and the minus capital P is to make it permanent. So by default, again, the database contains a certain state, but it contains the original values also. So when you reboot your system, it goes to the original state. Once you add the minus P, minus capital P, it puts that as the default value also. So if we look at that for the ports, here are all the ports. Let's say I want to see what Apache can connect to by default. Without T. By default, the HTTP ports allowed are 4438, 80, 4438 is not a default. I've added it on this system. So 80, 443, 488, 8008, 8009, and so on. People at the back might not be able to see that, sorry. So you see also here that there are some other caching ports that are allowed. So for instance, 3128, which some people use for Squid, is allowed by HTTP. By default, in the older versions at least, Squid is considered to be the same as HTTP daemon for networking connections at least. Okay. That concludes everything that's there by default in SELinux. So if you don't want to generate policies, if you're using a standard LAMP stack, these type of solutions would be very easy and convenient to use. If you're using, for instance, Zarafa or Oracle or any other custom daemon, that would not be a possibility. So what are SELinux policies? Policies are basically rules that have been created where file system labels are defined, access is defined, then they get compiled into a binary form and put into the kernel. So it works as follows. You have an SELinux policy database where all your policies are in binary form being loaded. A subject, a process, a daemon, a file gets a request that, okay, I want to be read or I want to be I want to read something. The SELinux module in the kernel will look at the database, see if it has the right to grant permission or not grant permission. If it grants permission, it can read the file. If it doesn't grant permission, you get an AVC error message in Verilog messages or in Verilog audit if you have the audit daemon on, or in Verilog secure depending how you have configured your security module. But by default, all these messages get on Verilog messages. If you want to have a full description with a more human readable version, then you should have the audit log on. So the SELinux database contains all the rules. It contains also all the booleans. So like I explained, you can get all the booleans by doing get as a bool. You can set them by using set as a bool, and minus capital P is to make it permanent. So now, how can you generate a policy? If you're running the audit daemon, all your error messages will get automatically logged in Verilog audit log. By default, it will generate more or less human readable type of error message. And then if you have the audit to allow tool, you can basically tell that I want the audit log to be cut for that daemon, and then tell audit to allow to generate a policy automatically. The policy that gets generated is a .te file, which is human readable. Then what you do is you do a check module. So what that does is it checks the database at the point of what you have generated, that what you're doing is not in contradiction with your database that's already loaded into your kernel. It will create a verification file. And then you have to create a binary package so that you can inject it into the database as a module package. What you do is you take the modular file with the policy itself and the verification, and you generate your .pp file, which can be inserted or installed into your database. The .pp file is a binary form. That is done because they don't want people to be able to read the database by default. Because let's say if you get to the kernel, or you would have an execution possibility within the kernel, you would be able to read the database then by default. So I'll be showing some of the files. So for people who use Zarafa, for instance, if you generate a file, it will create a module with the name that you gave it. It will create normally a 1.0 file, and then it will tell the module, what do I require? So I require that var_t be loaded, and it will tell you what types of labels it will be using, what classes it wants to use within the database, and what it wants to do with those classes. So you want to be able to read, write, search, and get attributes and create also. Then it will go through each daemon automatically, and it will tell what the daemon can do and what it can basically use. So in this case, for the people who know a little bit about Zarafa, it's a collaboration system with a web front end. By default, if you have SELinux installed, the Apache daemon cannot connect to the Zarafa socket. So what you're doing here is you're allowing the Apache daemon to connect to that socket specifically, so that it can get all the information from the Zarafa server. You allow it to connect to the home directory of the users and to the varlib user, because that is where Zarafa keeps all its files. Then because procmail uses spam assassin, it generates all the extra daemons. If you want to make it more modular like I've done, I've created separate, so what I do is I generate it and then I cut and paste into separate modules so that you can have it in later terms. But to understand policies easier, it's easier to let the automatic generator generate a big policy, and then you can play around with it easier. So procmail needs to also be able to connect to a socket, and as a manage needs to be able to unlink files so that it can give the right context to files which are without a context. So that's the Zarafa. I have a few other ones. I have to see which ones. So this is, for instance, what you would need with Dovecot. By default, the policy that has been generated was not compatible with the setup I had. So what you do is you generate a new policy, and it will allow you to log all the files basically and relabel files on the fly. Yep. If you want more information, you have the main project page. You have the official SELinux. You have Daniel Walsh, who is the official maintainer by Red Hat. You can find a lot of good information on his website. Then, of course, you find the RHEL or the CentOS wikis where you find information, Fedora wiki, and for those who use Gentoo or Debian, there are also separate wikis for that. Thank you for your attention, and are there any questions?
Sorry that I was late. Can you tell me in short what this SELinux, what will it do? I know SELinux from the books that I see on the screen.
Yeah, so visually, if you want to understand it, this is the most easy drawing. So the traditional way is this way, where you have your kernel, your file system, and your daemons. And basically, if a daemon wants to get to a file system, it asks the kernel. If it has the permissions, it will allow it to read those files, execute them, or whatever permissions it has. What you're doing with SELinux is you're loading a kernel module and a database. And within that, you are telling that, okay, the Apache daemon or whatever daemon you want gets confined to that specific sector and to that specific labeling, context, networking connections as per that compartment. So basically what you're doing is you are subdividing each daemon in compartments on the system itself. So if, for instance, Apache gets compromised, it's only that particular, and you wouldn't be able to go to other daemons at that point. That is the main idea behind it. And if you want to go to a more complex situation where you have multi-users, then you have to use MLS, whereby you would be able to use and define specific roles to daemons, that this daemon uses this role in this context and then allows only access to those files or those networking connections. That's the main idea behind it. Yes?
What's the use for packaging rules in a binary format? You told it was easier to protect it for right eyes
Yes.
see what the rules are, but I think you have only access to that file if you are root.
Well, the problem is, at least that's the only one that I found till now, is that if you have kernel execution rights, for instance, you write a module that needs to be loaded into your kernel, that gets like a driver, for instance, but in place of a driver you make a module that basically links up to the SELinux database and would read it out. That's to prevent that mainly.
Okay, but if you
It's only a bit of security to
Yeah.
security then.
Yes, but that is only done on the database level, not on the policy level, because the policies, you keep the source files and they will be available on the internet, so you can read the source file, but you cannot read the binary form that is loaded into your machine. You can only see what version you are using of that.
But if you are already capable of if you would already have been capable to look into the database, you would have the same access
That's, to everything.
disable SELinux token.
Yes. If you're running it as we run it today, yes, that is the only way to get into the system and get system-wide access still. If you're running MLS, that would also not be possible, because you would only be able to get access to whatever security level you are allocated. You would never get kernel access at that point. That is the difference. But that's a little bit complex, and I don't think I would be able to do that in 1 hour. Okay. Yes?
Is it possible to secure desktop applications as well, especially the high-risk ones that connect to the internet, mail client, web browser?
Yes, you can generate policies for Thunderbird that I've done already. The only one that I know that doesn't work well is OpenOffice on desktop level. That is because it does some strange stuff that I didn't understand maybe. But most of the desktop applications you are able to run them with SELinux. In the newer versions, Fedora 14 and higher, there is even a kiosk version which Dan Walsh has published on his website, and which should become mainstream and a separate spin within Fedora, which will run SELinux fully, even on desktop applications, and you will be able to basically have a kiosk mode with SELinux enabled. So even if a hacker gets access to Firefox, he would only be able to crash Firefox.
Yes. Then if there's some accidental malware or something, can be prevented.
It can be prevented from going to multiple. Again, within the application at this moment there is not enough attention to do that, but intersection between the applications is what SELinux more or less tries to do. So it makes a confinement from the compartment, for instance, for Firefox, and lets you crash Firefox and doesn't let you go to any of the other compartments.
But then can the file system be compartmentalized, like that the mail client can only
Yeah.
get to the mailbox directory and not to
Yes.
other directories?
That is the idea behind it also, yes. There was a question there.
There used to be a 7% performance hit. Do you know what the current numbers are?
The current number is 0.1% normally. In 2.6, 34 and higher. I have not tested it on other ones yet. I know that if you're still running 2.6.18, which is the enterprise Linux version of Red Hat 5, the performance hit is about currently 1%. Sorry, is about 1%. But again, if you are using it as a LAMP stack, that wouldn't influence it too much. If you're using it for custom applications, that might be an issue. And in the embedded world, I've heard from some other people that that is an issue. But they are working at that, and if you use newer kernels, which the embedded system tends to use, you are at 0.1%, so it is quite small. I know that few car manufacturers have started looking into this. Any other questions? The last slide. Yeah, so for those who want to see the slides, they'll be available tonight on that location.
Too small.
It's too small.
Height or the location? On the website. Now,
Now, can everybody read that? Yes. Okay.